first patent, which we're very excited about, and that covers key facets of our unique intellectual property pertaining to the hardware side. And we've got what I call a dual mode strategy, where we'll patent the things that are obvious and evident based on a quick inspection of the robot. There's also going to be a lot of things that will be our secret sauce, right? And so as we look at a lot of how we do a lot of the AI stuff, it's a combination of proprietary algorithms that we've developed in-house, coupled with off-the-shelf, readily available published papers or AI models that are available to the general public. And so really it's a dual mode strategy, and that allows us to not only move quickly, but allows us to truly adapt. And the AI space, Justin, it's moving so fast. The velocity of papers being published by the big leaders like Google Brain and Facebook and a whole host of other companies. It's really exciting. It's a great time to be here. And a lot of this technology that's being made available is really a source of inspiration, but often it's just a research paper too, right? And there's a lot of work to take that from idea to something that you can actually sell in production. And that's a big focus for us.
So like I mentioned, we're currently in EV1. So we still have EV2 to work through and then DV. And that's really about hardening our design and working out, any type of bugs that exist, so that when somebody gets it and their expectation is the thing just works, well, we've already went through the rigor of testing this thing and resolving any of these type of corner cases, bugs, etc. And it kind of then, to answer the other part of the question is, so when, it depends. So we have a couple companies that we're working with already on really early in their development and our development on how can they automate their workflow. So there's this one company that's working through like a drink filling scenario, right? So I think if it's something that if you're really passionate about, I love to listen and I want to help people out. So, give your 2-minute pitch an email, right? Send it over an email and we'll take a look. And, if we think that, both companies can help each other to go fast and deliver a lot of value to people, let's take a look, right? Kind of our beginnings. But like I mentioned, some examples of customers already. Fish processing, ornament making, those are certainly not within the WaveMaker portfolio. And we very much want to help any company that, is looking for a low cost, easy to use robotic arm for their application of whatever that might be. We will be providing EV2 units to them for their own testing and development. And then we would need to go through DV, and really DV is all about manufacturing buildup and testing those manufacturing lines to make sure that, can we build this at scale? So we plan to exit DV, and so mass production would start in July of next calendar year. And so you can look at, the time from now through that July period. We're partnering with a couple companies, Miso being one of them, using some of our early engineering units to help them flesh out their scenario. How are they going to automate it? Whatever problems they're trying to solve, and get that feedback from our customer. We really want to listen to customers, right? And tune our product so it actually serves their need that's really important for them. And so, how it kind of works at a really high level, hardware development is you'll start early on the process with, some folks call it a BOP, business opportunity proposal. You'll kind of create a early proof of concept. You'll go into an ASR architectural spec review where you look at the entire system end to end. So we're through all of that. Our ASR, we had 110 pages of what our architecture needs to be, both from a hardware to software. And then you go into EV1. So EV1 is engineering validation. It's really about taking that architecture that you designed and really the first design and implementation and manifesting into, what that architecture is, right? And then you really start your rigor of testing. You look at ongoing reliability, You look at, you start how am I doing my DFM, so design for manufacturing, very early on. And once you get to a point where, hey, we have tested out our architecture, we have tested that implementation of device, then you can roll into an EV2, which EV1s tend to be a very low volume build. EV2 for Ally, we're going to be around 10 to 15 units we'll build up. And so we'll, carve off some of those for, they're just going to go into test stands and doing reliability, lifecycle testing, durability testing, destructive testing. We want to know where these things fail so we can tweak those and improve the quality. And then a couple of the other units will go to some of our early partners, like I mentioned, MISO, for their own testing and implementation. And then the next phase after EV2 that's when you go into DV, design validation, where you're taking that now, matured design, bring it to your manufacturing. And so you're looking at supply chain, what are all the different components, sourcing, et cetera, what's my yield look like? What's my end of line testing look like? And then from there, then you go into mass production. Strategic direction from the company is that we will try to, as best we can, source in the US, but we'll have to source across the world. But we will manufacture in the US. We are avoiding manufacturing and sourcing from China.
Competitors, and have been for really decades in the automotive space and in heavy industry and manufacturing. But when you look at many of those challenges, Tesla was a classic example of trying to get that automation, the traditional automation system, every application. It's really difficult, and it kind of shows that there's a lot of limitation in terms of how those products are being embodied. And then if you move into spaces outside of a very controlled manufacturing environment, like hospitality, fast food restaurants, quick serve, all these other things, they're a huge, much bigger market actually, and they're completely underserved, right? The products aren't really designed to suit those applications. Narrow kitchens, lightweight, highly performant, and so many of those markets aren't able to access the product, and also because of the price point, right? So when I look at the competitive landscape, there are a lot of folks who are very focused on manufacturing. We're not there, right? And so that gives us an area where we can build a really sizable business and go truly solve a problem that they care about, that matters to them, and building a more of a tailored solution that goes into these other market verticals.
And so if that's the case, do you say, oh, all 9 billion people? Well, no, that's not realistic, right? But so what we're trying to do is, building off what I was saying before, is look at some kind of key scenarios, like using MISO as a start, right? In food automation. We have 3 other companies that are still within the food automation space. So we're taking kind of our early partnership learnings from food automation work with MISO and translating those into, other food automation type of, scenarios. And then from there, it's like, okay, well, we've looked at, general path planning, of course, all of the inverse kinematics and, AI and all that. And it's like, okay, well, what are kind of the next scenarios to go after and automate? And that's where, to bring it up again, Christmas ornament manufacturing, when you're glass blowing those ornaments, one of the challenges is that, of course, painting, because there's a huge labor shortage there. Imagine there's a glass blower and the dwell time between the different stations. Well, having an arm to actually take that glass before it's painted, and the cooling cycle. If you put it on a conveyance system, it could shatter, break, the vibrations of the belt and all that. So that is, again, it's like, okay, hey, we're building off the tech we've already learned from food automation, and it can go into these other industries. And then, we look at agriculture, construction. In construction, it's like, hey, if I look at a journeyman electrician, he has an apprentice. A lot of times the apprentice, they'll punch holes in drywall for, putting in a gang box. Well, it's like, hey, just mount a zip, rotor onto the end of the arm, and it can go along the wall and, cut out these gang boxes. Cool. It's using that same technology that we've already created. And it's really just allowing that journeyman electrician to come and say, hey, here's the motion I want you to do. And then they save that as a behavior that's now repeatable. And then there's some integration work for like, how do you lay that up onto the wall and, the whole layout. But there's this, fundamental technology that we're bringing to that new application.
Yeah, absolutely. Yeah, it's a great question. And when you look at the starting application with Meso, it's very much operating its own protective space. And so there's a protective screen with an interlock on there. So if someone happens to open the door while it's cooking French fries or other products, then it will shut down, right? And so in that environment, it's fairly simple. We're also thinking about environments and applications in the future outside of that, where it's more like a cobot, where it needs to work alongside people or work with other interlock systems. And the questionnaire was absolutely spot on. I mean, there are so many different variants of applications of the robot working by itself in the corner, and it could be a protective screen, or it could even be a light screen, right? If you pass through the light screen, it shuts down, or it needs to work alongside humans. And so the architecture is such that we could support a wide variety of applications now and also into the future. And so, with, again, the smart connected system, it allows us to deploy software updates in the future that, again, support more of the cobot scenario. And that's really a state that we want to get to because it allows and expands upon the pool of applications where we can truly help customers. Mitch, you want to add anything to that?
Yeah, that's a great answer. And then just, from a tech standpoint, we're looking at different sensors that we can include on board of the arm. And that's where it's, comes down to what Aaron's saying is application specific at times. Certainly we, at each of our joints, we'll have output encoders so we can look at torque, inferred torque at each of our joints so we can detect collisions, things like that, and then go into, safety modes just based on a pure motion standpoint. And then, that's where, again, just kind of restating what Aaron said, where you could kind of see Meso, the Flippy 2 frame in the back there. We're starting in an enclosed environment, and that gives us an opportunity to really incubate a lot of our tech in a, confined space. And that's where, looking at, customers and partnering with them on what are those non-enclosed spaces and how can we incorporate the right set of tech so that we are always operating in a safe mode.
So it's Ali's arm in addition to Ali's software up until the point where the robot arm ends. And so where Meso software, you can imagine the demarcation line. So Ali's arm can run independently, it can follow these gestures. But in the Meso application, we just have a software interface, using an interface called ROS. And then from there, Meso systems able to orchestrate our motion. So Meso have a lot of the vision systems and all the other software stack built up, and it allows them to quickly interchange Ali into the application, or other OEMs who wish to use Ali as part of a broader system. That same architecture gives them the flexibility that they need to talk to it via API or ROS2 or some other interface, right? There's a myriad out there, particularly industrial automation, and our aim is to support those to enable both the model that we talked about now and also future state models. Because it allows us to kind of manage that appliance for you, but it's not mandatory. And so we can do offline updates, and there will be applications, specific applications where a customer won't, for whatever reason, have an internet connection available, or maybe the internet connection spotty. And so that allows you to do the update with our device, like a laptop. And so you can actually connect into it and do configuration and also deploy the latest software update. But the best state, honestly, the easiest thing for the customer is if you connect it, we'll manage it for you, just like your smartphone, just like your Google Wi-Fi router, or just like all of these other modern appliances that we love. They got better things to do. They got to run their business. They want to make money. And so we want to make sure that we keep them up and running with the latest software and security updates. And so a connected device truly makes that seamless for us to deliver that best experience.
lot of different ways to measure robotic arms and manipulator speed. One of those is looking at the TCP, or tool center point. It's basically the end of arm interface there. And so our arm, we have it spec'd at 1.5 meter per second. That it's from an isocube standpoint, from one point to the other, translating across multiple joints. And then depending on the joint, they have different velocities in and of itself. Currently in our testing, we are actually exceeding that 1.5 meter per second. So we'll likely intentionally bring that down just from a safety standpoint and an overall reliability standpoint. So we're actually, an orthopedic surgeon reached out to us, just transparently. It's been a lot of great product scoping and requirements gathering discussions. I would say I would like to enter that space, but there is a lot of requirements to become a medical device certified unit. And so that will be a journey for us. And so we're looking at, our other approachable, customer scenarios, automation scenarios, where we can continue to build and innovate on the tech. And then as the rest of our tech stack increases, we'll strategically look to enter into the medical space, but we'll need to think consciously on how we do that from a focus and timing standpoint.
Camera to watch Mitch as he's making those gestures, or the customer is making those gestures. And then we process that video with proprietary algorithms to make a determination based on what the user wants us to do, and then control the robot accordingly. So there's a lot of deep IP and know-how in that space, call it alley intellectual property, that has gone into developing this particular approach. We think really truly reduces the barrier to entry and democratizes access to it.
Yeah, exactly. So when you saw me standing up there, I would flash a double peace sign. Right now, that's just a temporary gesture, but what that does is it puts it in a joint enabled mode. And then you saw me at certain times flashing a, hang loose sign, and, just temporary gesture for now, but what that was doing it, the vision was looking for that particular gesture, and that would save a waypoint within my motion plan, right? And so you could see at other times I would flash a thumbs up, and what that meant is I was in an active shadowing mode. So this is where I had my right hand up, and I could, move my hand, translate it, and that would translate to a joint rotation. Let's say at like J3, I would have here, I would go like this, and that's directly translating to if a human arm, J3 was your elbow, it's translating to that specific motion. And so then what you do is like you have relative movement, so if I translate a number, some certain distance here, that translate to a certain joint within joint space. And then so kind of what Aaron was talking about is there's a lot of work on translating the intent. So when there's a certain time where I had another gesture and I was translating this, and that was a planar motion. And so when we want people to be able to just train these arms to just show and tell, it's whatever they're doing, it's looking at, well, what's their intent? They're showing the arm to this certain motion. What do they actually want the arm to do? And that's where we have, we've written already some IP, and that's where we're going to go and develop additional.
Legs to this stool. Number one, it's about building a product during the engineering stages. So, during the engineering EV1, EV2, and DVT stages, we do a lot of work to qualify all of the components so that we understand what their future failure modes may look like. And then we make sure that we use those components inside their specified ratings from the original manufacturer. And sometimes we have to push those components to their boundary, to the very edge, to find out what is actually the limit of this part, how much do we have to back it off to make sure. So that's one element of preventive maintenance, is understanding what is the failure mode of any particular part. How do we make sure that these parts are truly reliable? The second piece is actually applying technology. And so with the product out in the field, with first initial units, and even during the EV2 stage that Mitch talked about, where NISA will be receiving units, we'll be collecting data, a lot of data off these robot arms. And that helps us to build really interesting predictive ML models. So we can use the power of AI and ML to understand, well, this is the normal operation mode for a motor and current and temperature and velocity and all these other things. And we can put that into a proprietary algorithm and start to map, that's normal behavior. We just detected an incorrect behavior, and start to tie that back to when would that part fail. And that's really important because many parts don't just suddenly die, right? Sometimes they do, but in many cases, they can take a while to go through a failure mode. And so that's an opportunity for us to detect it and basically build a AI model that is truly predictive in nature that can help our customers schedule maintenance, right? So if we detect that a motor in one of the joints of the robot is starting to fail, then we can schedule an appointment, get the motor replaced, and the customer has a really great experience because at no point in time do they experience downtime as a result of that motor failure. And so there's a lot of things that we can do to really enable and make the product smart and intelligent and get ahead of predictive and preventative maintenance.
We have some work to do, but when I think about attainability, it's really about, if there's different types of customers and applications. There's those that, from a capital expenditure standpoint, they just want to outright buy the arm. Cool, we can support you. And then there's some others, like I think about industry United Rentals, as an example, just to name one company. They can rent devices by hour, by week, by few days, by month, and we really want to explore and innovate within that space. And so, how can we provide an automation solution for somebody that wants to pay by month or by week or whatever that reoccurring kind of scenario that they have, and then therefore that would effectively make us have a reoccurring revenue based off these deployed units. And then building off what Aaron was saying is because these are smart arms, they're connected in the ideal scenario. We look at that data, we can understand, hey, it's been deployed at this site. Here's kind of the conditions. We have other behaviors that we're bringing to that table to help, solve whatever that automation is. But then also from a maintenance standpoint, we know how well that robot arm is going to perform within that certain application, and we can support that person. So it's not or group or entity. So it's not just the individual that has this arm for, let's say, a week, but it's also all of the other technology and services and support that Ally's bringing to help support that specific person's application.
I want to invite everyone to visit allyrobotics.com to learn more about our Series A round, which is scheduled to end on September 29th, just a few weeks from today. And I want to say thank you very much, Aaron and Mitch, for all the great information you shared today.
Thank you, Justin. Thank you, Aaron. And thank you, everyone that attended.
Thank you, everyone. Thank you, team.
Let's just stick to robotics.
Invest in the future with Ally Robotics.